Hello. So we are on to lesson 4, and we're going to be talking about sea turtle migration and how they navigate. So navigation is going to be a topic that we're going to talk quite a bit about. So I think I'm going to start with a program. It's a big ocean out there, as you can see behind me. And how do they find their way to their nesting areas where they were born and track back and forth across our oceans? We're going to be discussing this. So what I need to do, okay, here we are. Lesson number 4, sea turtle migration and navigation. Let's start. Okie doke. This is incredible. Leatherbacks are not only the largest reptile, the heaviest, they actually travel the longest on their migrations. Across our oceans, this is 7,000 miles that they're migrating across our oceans. And it's comparable to our great whales and how they migrate as well. So how are they doing this? This is a big question. Our sea turtles breed over in tropical areas like Papua New Guinea and over in Asia. And then what they'll do is usually they'll sense the light changes, just like we do in spring. When we spring ahead an hour, that stimulates them to migrate across our oceans, make a long migration. It takes several months. And they're actually after their prey, which are the jellyfish, or jellies, I call them. And they'll come up to California, and again, they'll follow the jellies all the way until about November and then go back. Again, all the other turtles don't migrate as much. They kind of are resident. They stay around their coral reefs, and there's not as much migration. However, we do get loggerhead turtles that go from Mexico all the way to Japan, and that's been studied by a famous turtle biologist named Dr. Wallace Nichols. And okay, so this is what's incredible. And this journey is like the size of 2 Texas states, or 2 United States. It's really big. It's a long distance. Okay, so how are they doing this? Well, believe it or not, I love the movie Finding Nemo because these turtles are using the current highways. There are current highways out there that are huge called gyres. And this, in the movie Nemo, this was Dory and Marlin. Here's Squirt here. What was the name of this turtle? He was kind of a funny guy. He had an Australian accent, and he was a surfing dude, and his name was Crush. And we're going to learn who Crush represents in the 7 different species of turtles. But let's go on and talk about migration. So sea turtles are using these gyres. We have huge currents that are very slow moving. They're kind of just pace along like walking speed. And in the northern hemisphere, they go clockwise, where in the southern hemisphere, they go counterclockwise. And turtles are using those currents, we think. And there's studies that are finding out that they are using them. And that's what triggers them to come over to the feeding grounds here. And then in fall, when we fall back an hour, that's when they'll go back to the nesting grounds, okay? So pretty incredible. So how are they doing this? In the middle of the ocean, as sailors and boaters, you have to have a special license because you have to use the stars to navigate. You have your electronic equipment, but if all of your electronic, like GPS, goes out, you're in trouble, and you rely on the stars. And a lot of birds use this method. They follow the moon, and a lot of the turtle biologists believe that leatherbacks aren't really relying on the stars as much, because stars, we can have overcast and we can't see the stars. But I think in a way, I mean, it is helping them to follow the moon and know where the moon is located. And if they can see stars, which is limited because their vision they don't think is very good, adapted to air environment, but they can see well below the water and collect a lot of light. So basically, turtles are doing something different. They have internal compasses in their bodies. And in fact, in the leading edges of their flippers, they have, and if you can see, this is how we navigate with our North Pole up here and South Pole. It's like a big magnet. And what it does is it radiates these lines that we put on maps, our latitudes and longitudes. And as you can see, they get kind of narrower up near the poles because the force, the magnetic force is pulling them in. And you can do a little experiment here. You can use a magnet. This is just a magnet with saying North and South Pole. And if you get some magnetic filings, you can actually put these small chips of iron out there and you will see the radiating lines of force and this is like what's happening. They're detecting these lines of magnetic force. Okie doke. And this is what humans can see. They may be seeing even more definition. The red areas are where there's high magnetic anomalies. And you can see Hawaii in the middle here, but they are possibly, I mean, we don't know, we're just starting to study this, but how they can actually pick up really fine details. But magnetic cues are thought to be the main method of how they are migrating back and forth across our oceans. Okie doke, so is this unusual? Well, no, because here, this is a picture of homing pigeons in the old days. We used to use homing pigeons to deliver messages to people, just like our mailbox, but instead of that, we'd give the bird a little message and then it would go off and fly and deliver that message. We're still using this today when we have power outages or we have earthquakes. I mean, this is a way we're doing this. The magnetite is located in their brains and they are detecting magnetic fields, navigating like our leatherbacks, sea turtles, and the other sea turtles. And believe it or not, we found it in humpback whales. And this is a poor little calf that died in Hawaii. I'm right there, and my colleagues, and this is a veterinarian here, but we were actually trying to save this poor little calf, but unfortunately it died. And then we did a necropsy or dissection, and we discovered there was magnetite in the front part of the brain, and they had this magnetite in their leading edge of the flippers. And that can be very helpful in how the humpbacks are finding the Hawaiian Islands in the middle of the ocean. And butterflies. Butterflies are using magnetic fields. They have magnetite as well. And it's very fascinating. And you can read more about this in your libraries and online, but a lot of navigating critters that migrate use magnetite and magnetic cues to find their way around our Earth. We would be totally lost in the middle of the ocean, but they can find their way back and forth. Okay, here's a little video that you might want to explore to learn more about the Earth's magnetic fields. And we'll start this.
Mapping of magnetic lines of force. To map lines of force around a bar magnet, fix a sheet of paper to a drawing board. Place a bar magnet on the sheet of paper at its center. Adjust the drawing board and the north pole of the bar magnet along the GN by using a compass. Place a plotting compass near the bar magnet. With a pencil, mark the direction of the north pole of the plotting compass, say P1. Now, move the plotting compass in such a way that the south pole of the plotting compass is in alignment with the P1, and again mark the second point, P2, shown by the north pole of the plotting compass, say P2. Join P1 and P2 and mark the direction of the deflection. P1, P2 is a line. By repeating this action, many more points may be obtained, and the line joining all these points is called the line of force. To show the magnetic lines of force using iron filings, take a cardboard. Place a bar magnet at its center. Now, sprinkle some iron filings on the cardboard. Tap the cardboard gently. All the iron filings get aligned themselves in the direction of the magnetic field. The pattern in which these iron filings form a line is the direction of line of force in that area.
Okay, smell, believe it or not, is something also very important. When they get close enough to their islands where their natal nesting grounds are, where they were born, that means natal, they are actually using smell as another detection, another way of finding their way back to the islands where they're born. Their memory, their brains are very small, little, like size of a peanut for a big leatherback sea turtle, but they're so sophisticated. Their whole body is a brain. They're just amazing, amazing critters. And, you know, they're just like a computer and doing all these things and have memory and memorying all this stuff. So anyways, very fascinating. So our next lesson, we're going to be talking about sea turtle feeding adaptations, ecosystems, and conservation. And this is a big leatherback sea turtle that you can see some adaptations on its face. So let's go on to that program.